All right, so here's the second part of that derivative lesson. The reason we have two parts is because my computer was running out of storage, so the video started to act up. I think you saw at the end. So I'm going to go back to number 4, because the video was okay up to here, and to know that there's now a shortcut we can use. Why didn't I tell you this at the beginning? That's a good question, because you have to know limits, and if I show you the shortcut, you'd never go back. But now we're going forward with the shortcut. In the shortcut, we have a few of them. One's called the power rule, where you take the exponent times whatever's in front and then subtract 1 from the exponent. That's simple. So in number 4, the exponent's 8. 8 times 1 gives me 8. Subtract 1 from the exponent and it's over. Yeah, it's that simple. Number 5, I don't see an exponent, so I write it as an exponent. That's writing it calculus friendly, so I can do rules. So this rational or radical is now written with a rational exponent. Now I can go 2/5 times 1, which is 2/5. And now I need to subtract 1 from the exponent. Now, subtracting 1 means any common denominators. But I'm going to give you a quick shortcut to subtract this for these rules where we're going to subtract 1. So because you're subtracting 1, you're just going to simply go the denominator, subtract the numerator. So 5 take away 2. What's left over is 3/5 whenever you're subtracting 1. Just a quick way to do that. Number 6, I need to write it as not a fraction, not a radical, but just an exponent, a power. So 1 over x cubed can be written as x to the negative 3. Now it's calculus friendly, where you can go negative 3 times 1, subtract 1. Be careful when you're subtracting with negatives, and that's a beautiful answer. You don't need to write it without a negative exponent. Be comfortable leaving it. That is the final answer. All right, some more rules. Same thing to do with the power rule. If you have a constant, the derivative is always 0. That's because the slope of a horizontal line is 0. Here, this is that concept of a power times whatever is in front. You multiply them together and subtract 1 to the exponent. If there's adding or subtracting, you just do each one separately between the plus and minus signs and you're done. So let's practice that. So in number 7, can you use derivative shortcuts? So the power rule says 3 times 2, that's 6. Subtract 1 to the exponent, that's now 2. And then the derivative of 7 is 0. And of course, you don't need the plus 0. It's only 6x squared. So again, derivative rules. And notice adding and subtracting, we just do each one by itself and put them together as a final answer. 5 times negative 1, that's negative 5. Subtract 1 from the exponent. Keep going. 3 times negative 8, negative 24. Subtract 1 to the exponent. And then 1 times 2 is 2. And then when you subtract 1 to the exponent, you get 0. And next to the 0 is just 1. So in other words, if you have a linear, there's no longer a variable left. So 1 times 2, so the derivative of 2x, 2. The derivative of 5x, 5. That idea. So if you're finding the derivative of a line, it's just what the slope is, and there's your answer. No variable left. Number 9 and 10, we need to write calculus friendly. So for number 9, to write this calculus friendly, we're going to write down x subtract 4 to what exponent means the same thing as square root. So 1/2, and we still have a subtract 1. So that when I take the derivative here, losing power with my pen. All right, so when I take the derivative here, we're going to go 1/2 times 1 in front, did it. Subtract 1 to 1/2, so like 2 take away 1, but this one you subtract 1 is going to give you negative 1/2. It's okay. And then the derivative of negative 1 is 0, and I don't need to include it. Number 10. To make this calculus friendly, recognize there's a monomial in the denominator. That way, I can separate into 2 fractions to make it easier to do the calculus rule. Now, the first fraction simplifies to 1 over x. The second one can be written as 2x to the negative 2. So this can be written without a fraction as a negative exponent. And 1 over x can be written as x to the negative 1. Now, when it's only powers, then I can use the power rule. So what's the derivative here? Negative 1 times 1 in front, that's negative 1. Subtract 1 to the exponent. That's simple. Negative 2 times negative 2, that's plus 4. Subtract 1 to the exponent, and it's okay you leave the answer with negative exponents. Here's some more rules. All right, I'm back. The product rule. So when two functions are multiplying, there's a rule to do the derivative. And the rule is the first times the derivative of the second, that should be an S, plus the second times the derivative of the first. So in this example, it would be the first times the derivative of the second plus the second times the derivative of the first. So there's the product rule. We'll have many times to practice that throughout the school year. So let's do it for the first time. The first times the derivative of the second. Now 2 times 1, and subtract 1 from the exponent. The derivative of negative 5, 0. That's done. Plus the second, x squared subtract 5 times the derivative of the first. So the derivative of 3x is just 3, and the derivative of 2 is 0, so we don't need to go plus 0. And that's it. You don't need to simplify it. Let's practice that again. Can you do the product rule? How do you know it's the product rule to do this? So do you see 2 being multiplied beside each other? So we're going to use the product rule. The product rule is the first, that's negative x to the fourth, negative x squared plus 6, times the derivative of the second. Now the derivative of 4 is 0. The derivative of negative x is negative 1. Plus the second times the derivative of the first. 4 times negative 1. Subtract 1 from the exponent. 2 times negative 2. Subtract 1 from the exponent. And the derivative of 6 is 0. So we don't need to go plus 0 at the end. No need to simplify. All right, here's another rule we can use called the quotient rule. That's when we're dividing. And so the rule for when we are dividing, we have a bottom and a top. So we take the bottom times the derivative of the top, subtract the top times the derivative of the bottom, and then the bottom squared. That's what we're going to do. So for this one, what it would look like is you would take the bottom times the derivative of the top, subtract the top times the derivative of the bottom, and then you would square the bottom. That's the rule. A little bit more involved, right, when we do the quotient rule. So let's try it. We don't need to simplify these. Just practicing the rule. One big fraction line. Here we go. The bottom times the derivative of the top, and the derivative of 8x is 8. Subtract the top, 8x, times the derivative of the bottom. 2 times 2, that's 4, and subtract 1 from the exponent, 4x. The derivative of negative 5 is 0, so it's just 4x. And then take the bottom, use parentheses, and square it. And you just did what's called the quotient rule. Let's try that again for number 14. Can you do the quotient rule? A nice long fraction line, and here we go. The bottom times the derivative of the top. So the derivative of x squared is 2. Subtract 1 from the exponent. Negative 4x is just negative 4, and 3 is 0. So there's the derivative of the top. Subtract the top, use parentheses, times the derivative of the bottom. Now the derivative of 1x is 1, and the derivative of 2 is 0. So the derivative of this is just 1. That's the slope of that line. And then you take the bottom with parentheses and square it. Done. All right, let's try to put it all together now. So more practice with derivatives. Here we go. Big calculus lesson. I'm proud of you. Find the derivative of each function using first a limit. So let's review what that's going to look like. So if I'm going to use limits and I'm given an x value, I'm going to use this formula. I'm going to go the limit as x approaches 3, f at x subtract f at 3, and then x subtract 3 in the denominator. Much simpler than the one with h. But that's only if you know the x coordinate. So f at x is negative 2x squared plus 10x. F at 3, when I plug in, 3 squared is 9. That's negative 18 plus 30. That's 12. And that's x minus 3. Next, I'm going to see if I can factor that. Remember to write the limit notation each time. So to make factoring easier, I'm going to factor out a negative 2. That's x squared minus 5x. Subtract 6. Then I'm going to continue to factor the limit as x approaches 3. Should be a 3. And that is, factor that, what's left over. That's negative 6 and positive 1, right? No, I had you wrong. Negative 10x squared plus 12. Oh, I had to subtract it. So notice I got 12, but I had to subtract 12. Well, when I do that, the sign changes. And why did that matter? Because when I factor, it's negative 2 and negative 3. And why does that matter? Because I need that whole to divide out. I need that x minus 3. So when I made a mistake, I didn't pout about it. I went back and figured out where did I make that mistake so that the whole would divide out. Now it's out. Now I can substitute in. So at 3, well, first of all, plug in 3 now for x, and you get 3 take away 2, which is 1, and then times negative 2. So the slope there is negative 2. Then, well, that's it, right? That's the answer we're looking for. So in other words, the derivative at 3 is equal to negative 2. So not using shortcuts, but limits, could I still get the answer? Now with shortcuts, it would be a lot easier, right, to do the derivative and then plug in 3. Let's do it again with limits. So if I want to find the derivative here, and I want to find the derivative at negative 7. So right away, I'm going to put that in, the derivative at negative 7. Because that's what I'm doing right away with this formula. So the limit as x approaches negative 7. What's the slope as it's approaching negative 7? So it's f at x, which is x cubed minus 2. Subtract. Now I need the y coordinate. So if I plug in negative 7 here, I need to know what negative 7 times negative 7 times negative 7 is. So what's negative 7 cubed? I didn't even think of it like that. Here, let me do it on the side here. So that's 49 times 7. Why not old-fashioned way, right? 28 and 6 more, right? That makes sense because I recognize that number. And then we're going to subtract 2 to that. So that'd be 341. We're going to come back to this in a second. Now, the denominator would be x subtracts negative 7. So that's why it's a plus 7. So we're going to continue on here. So the derivative at negative 7 is the limit as x approaches negative 7. We're going to combine like terms, and we're going to get back to negative 343, x plus 7. I recognize that negative 7 is a 0. That's what makes it indeterminate. So I'm going to use that fact to do a synthetic division so I can factor it, doing a difference of cubes. So I'm going to do that. One, 0x squared, 0, and negative 343. Just seeing what I'm doing wrong, because this should be, the remainder should be 0 if I did this correctly. $49, and then a negative and a negative. What am I doing here in terms of seeing this? Can I factor a difference of cubes? I know I'm doing something silly wrong here. So 1, negative 7, positive 49, and negative 343, which doesn't give me a remainder of 0. So I'm trying to think, what did I do wrong here with negative 7? You probably see something that I don't see. 1x cubed, 0x squared, 0x, negative 343. Negative 7 is not a 0 for both. What did I do wrong? Because negative 7 won't give me 0 over 0. So this is a difference of cubes. I'm going to think of positive 7 here in terms of what's happening. All right, I'm going to